Okay, problem 10.7, find the absolute maximum and minimum in the interval 1 infinity of this function. F of x is the integral between 0 and x minus 1 of this integral, right? And they give us a hint, but we will use it later. Okay, in order to find the maximum and maxima minima of a function in an interval, if it's continuous, and this one is because it's an integral, and we know that integrals are continuous, we want to find its derivatives and see where it will be. This derivative is 0, right? Now this function is an integral of differentiable functions, so it's going to be differentiable, right? Everywhere. And so now all the extrema will be given by the points where the derivative is 0, right? The value of the derivative here is the derivative of x minus 1, which is 1 times this evaluated at x minus 1. So this is e minus x minus 1 squared minus e minus 2x minus 1 equals, and then where is this equal to 0, right? Now the exponentials are never 0, and they're injective functions, so that means that this will be 0 when the arguments of the exponential are the same, right? So we have minus x minus 1 squared is equal to minus 2x minus 1. And so let's see. Then we have this is minus x squared plus 2x minus 1, and this is minus 2x plus 2. We take this together, so we have this is x squared minus 4x plus 3, right? And then we take the roots of this, so this is 16 minus 12 over 2, so 2 plus minus, and this is 4 square root of so on, right? So 3 and 1, there are the two roots, two possible roots, right? So now let's see what happens between 1 and 3, and then between 3 and infinity, right? There are two possibilities, right? So f prime between 1 and 3 is going to be, let's see, this is going to be, for instance, at 1, this is 0, right? So this, yeah, at 0 it's 0, obviously. So let's see, at 2, this is e to the minus 1 minus e to the minus 2, right? E to the minus 2 is smaller than e to the minus 1, so this is increasing in this interval. And after that, yeah, this is going to be decreasing, right? Right, so we have at 3, there's a maximum, obviously, and we have f at 3 is a maximum. Then the function is decreasing after that. And at 1, let's see, the function at 1 is 0, right? This function, so it's a minimum, right? Because this integrand is yeah, well, yeah, it's at 0. At 1 it's 0, then it decreases until this the value at f3, and then goes down. But now let's see where, so let's see, f at 1 is 0, f at 3 is a maximum, right, value wherever it is. What happens at infinity, right? This is going to be decreasing. Is there a limit, a lower limit to this function when this goes to infinity? Now, so now we have to compute the limit when x goes to infinity of f, right? And so this is the limit when x goes to infinity of the integral between 0 and x of x to the minus x squared or t squared dt minus the limit when x goes to infinity of 0 between 0 and x of e to the minus 2t dt, right? Now this is where the hint comes in. This is going to be the square root of pi over 2, and this, well, this is an improper integral, and we're not going to go into how to compute this, but this is, we have this integral, so this is just minus 1/2 of e to the minus 2t between x and 0, right? And so we know that this is 1 plus so 1/2 minus 1/2 minus 1/2 e to the minus 2x, right? Now the limit when x goes to infinity of this goes to 0, so this is just the square root of pi over 2 minus 1/2, but this is greater than 0, so the minimum value that it reaches at infinity is going to be greater than 0, which is the minimum. Okay, so the absolute minimum of this function, it's at x equals 0, the absolute maximum is at x equals 3.